Hi, I'm Pat. All right, we're still doing some more graphing, right? In this case, we're going to graph this y equals cosine of x over 2. And in general, you're going to be graphing these y equals maybe a coefficient in front, so a. And then it could be either sine or cosine for different problems, but some trig function, cosine in this case. And on the inside, the argument of the trig function, there might also be a coefficient, right? That's the b. So what I would start with, if I were you, is in the problem that you're working on, make sure that you get a handle on what those a's and b's are. The a is the coefficient in front of the trig function, so just 1 in this case. And why are we doing this? You remember a is the amplitude, right? So that would stretch the graph vertically. In this case, I'm not stretching it at all, so I should expect it to go no higher nor any lower than the original cosine graph, which is what? Up to 1 and down to -1? You know that. But what was I doing? I was trying to get a handle on my a's and b's. For this problem, b would equal the coefficient on the inside, the argument of the trig function. And you can see that x is divided by 2, so I hope you can also see that as a coefficient, I would be looking at that as 1/2, right? 1/2 times x. Now, as a reminder, I did write it up here, but the reason why we want to know what b is because the period for both sine or cosine is going to be 2 pi over b. So for us in this problem, 2 pi over 1/2, which simplifies to 4 pi. And here's why that's important. We're going to graph this. You know that. Those are the directions. So I'm going to get myself ready with this xy plane. But the reason why the period is important now then is that these tick marks along the x-axis, you might notice I left them blank at first when I'm doing one of these problems until I get that period. So why is the period important? That's going to tell me that always starting at 0, right? But I'm going to hit one full period when I reach 4 pi, okay? And the way that we're learning to draw these graphs is that we take that one period of either sine or cosine and break it into those 5 key points. Quick spoiler alert, that's what I'm getting myself ready for here, right? Just to ring a bell for you in terms of the key points. The maximums, the intercepts, the minima, intercepts, the maxima, okay? So back to my graph and my tick marks. I know I'm starting at 0, and I want to hit those 5 key points within that one period of 4 pi. So start at 0, and I'm going to have 5 key points. So 1 key point, 2, 3, 4, 5. That's going to be 4 pi. Let me say that again. For a different problem, that's going to be a different value. Use the same formula, 2 pi over b. Get a handle on your b, get your 2 pi over b, get this value in your problem for the period. And then in your xy plane, start at 0, and that's one of the key points. Second key point, third, fourth. At the 5th key point, that's your period. Okay? And then break it down from there, like 4 pi. I'm going to cut it exactly in half and get 2 pi. Cut that exactly in half and get pi. And see, here's the deal, guys, is this was a really nice number for me. 4 pi breaks easily into 2 pi, and that breaks easily to pi. But no matter what your value is, no matter what this expression is in a different problem for you, just cut it exactly in half, and that goes here. Cut that exactly in half, and that goes here. And then do a little bit of arithmetic to figure out what goes here. And again, I got an easy one. What goes between 2 pi and 4 pi? 3 pi. Okay? Use that same logic, though. I hope it helps you. And here's how it translates to the work that we have to do yet, too. Those 5 key points. Now I know that the first one is at 0. I already mentioned that a few times. We're always starting right there. So the x-coordinate, oops, I'll even go to green here for this. The x-coordinate is going to be 0, comma. And I'm going to keep you in suspense for just a minute in terms of the y-coordinate. But I'm only keeping you in suspense because I want you to see why we did what we just did. Now the intercept is going to have an x-coordinate of that first tick mark that you figured out. Okay? Comma, and we'll fill this blank in a minute. The minimum The next key point, go to your next tick mark. That's going to be the 2 pi, comma, this is going to be a 3 pi for the next intercept. And the maximum is going to be at 4 pi, comma. All right, good. Again, try to get you guys to see the connection here between these 5 different x coordinates that I've already got myself ready for and the 5 different tick marks that I laid out on the xy plane, okay? And it all comes from the period, okay? All right, now let's get those y coordinates. We've been in suspense long enough. So max, intercept, min, intercept, max. And what that comes down to then is your basic cosine graph. I'll even do it quickly in red. Your basic cosine graph, you know, starts high, goes through the x-axis, comes low, goes back up through the x-axis, and then ends high. That's one period of the cosine graph. And then you just have to figure out, okay, how high does it go? Your basic cosine graph, I think we've already said it, is as high as 1 and as low as -1. And since there is no amplitude other than 1, there's no multiplier, I'm just going to fill in. You ready? The maximum is 1. The intercept is always a y value of 0 because it's intercepting the x-axis, right? The min is going to be -1. The next intercept also 0. And your max goes back up to 1. So those y coordinates come from your knowledge of what the basic cosine graph looks like. And if this were a sine problem, you just got to be thinking about your basic sine graph. Okay? We're in good shape. Let's start plotting this. 0, 1. I'll be right about there. Pi, 0. 2 pi, -1. There. 3 pi, 0. 4 pi, 1. Okay. I haven't labeled this yet, but that's going to be 1 on the y-axis. -1, -2. All right. Then I would try to connect the dots here and be kind of smooth, fluid, nice rounded curves like that. And that's pretty good. But read the directions. I think they also specified for us to do 2 full periods. Okay, and all that means then, that's why I've got this space over here, is that where we left off, we're going to just do those 5 key points again, okay, but for the next period. So I continue on that x-axis with those tick marks. And again, mine was conveniently pi, 2 pi, 3 pi, 4 pi. So the next one is going to be 5 pi, 6 pi, 7 pi, 8 pi. But if your period wasn't as friendly as what I'm getting for this problem, just follow that same arithmetic, okay? All right, so now back over here, I'll just include a second row of these 5 key points from my second period. And where did I leave off? 4 pi. That's the same, 4 pi, comma 1. And very important, what I mean by the same is these are the same points. 4 pi, comma 1, where the first period ends is exactly where the second period's beginning, okay? It's important to realize those are the same point. Then, though, I'll go to 5 pi, comma, this is an intercept, so it's going to be 0. 6 pi, this is another min, so -1. 7 pi, intercept, so a y value of 0, and 8 pi, back up to that max of 1. Now let's plot those, okay? Let's plot those, and I'll say again that first point of the second period is the last point of the first period, so you've already plotted it. Then 5 pi, comma 0, 6 pi, -1, there, 7 pi, comma 0, 8 pi, comma +1, there, and then let's try to connect the dots. Smooth, fluid, hopefully, nice curvature, and that's our graph, okay? I don't know about you, but I think it's kind of fun. Just make sure you try some on your own.